Welcome to this video lesson on organic chemistry nomenclature. So this is episode 3 where we're going to look at functional groups, and so far if you've been following along we've only looked at hydrocarbon organic compounds, and today we're going to introduce some new atoms using functional groups. So functional groups are specific atoms in an organic compound that are commonly occurring together, and they will determine the properties of that compound as well as the reactivity. So let's start with the first type of functional group and the first type of special compound we can say, and that's alcohols. So alcohols are determined by the functional group OH, which is hydroxyl, and as you can see on these diagrams. So let's go ahead and try to name these structures that I've drawn here. So starting with the first one, you may remember, and if you need to recap, try to check out some of the previous videos about how do we do basic nomenclature. So in this first compound, I've got one carbon atom. So I'm going to use my prefix chart. One carbon atom has the prefix meth. Now, if this was just a simple alkane, then it would be called methane. But it's an alcohol because of this OH group, and what we do for our nomenclature is we change the ending from ane to -al. So alcohols end with OL. So we're going to call this compound not methane, but methanol, which I'm sure, you've probably heard of that before, right? By the way, these dashes, these represent H's. I just didn't draw all of them in, but those represent hydrogen atoms. Okay, so I've just highlighted the functional group here, which is the OH. So you go ahead and try the next one. We'll do it together if needed. I've got a 2-carbon compound, so let's look at our prefixes chart, which is 2 carbons is eth. And if this was just a simple alkane, I would just call it ethane. But because of this OH group, I know it's an alcohol. So I'm going to call this not ethane, but ethanol. Okay, we're going to change that ending to OL. Hopefully that makes sense so far. Let's continue on. So the third example is a little bit more tricky. It's a 3-carbon parent chain, and my alcohol is actually on carbon 2. In this compound, I'm going to have to indicate what carbon number the OH is on. So I'm going to number my carbon atoms 1, 2, 3. Now, I didn't have to do that for methanol and ethanol because the OH is automatically just always on carbon 1. But in this compound, I can see that the OH is on carbon 2. So again, my 3 carbons indicates it's a prop. So not propane, but propanol. But because the alcohol or that functional group is on carbon 2, we're going to call this propan-2-ol. So this means that the OH group is on carbon number 2. This is the new nomenclature, so this is the preferred method. There is an older way of doing this as well called 2-propanol, but I'll just use the new nomenclature for this video lesson. Okay, so this structure is called propan-2-ol. Okay, let's try one more alcohol. As you can see, it's a 4-carbon parent chain. Now don't be confused by this. If you guys remember from previous lessons, that's a substituent group. So CH3 is a substituent group, and that's called methyl. The alcohols are over here. There's actually 2 of them, or 2 OH groups. Now, when we do our nomenclature, we have to number our carbon atoms, and one thing to note is that I've got a substituent group and a functional group. And when you have this situation, the functional group takes priority. So functional group, I'm just going to say, takes priority. Now, if you have a compound with multiple functional groups in them, there's another priority ranking, but we can maybe look at that a little bit later. So what I mean by the functional group takes priority is that because OH is on the carbons towards the right, I'm going to call this carbon 1, and we're going to number it backwards like this, because we want to give the functional group the lowest carbon number possible. So if for example, if I numbered this one number 1, the OHs would be on 3 and 4, and so that's kind of defying the rule. We need to give those functional groups the smallest number possible. Okay, with that being said, to name this compound, it's a 4-methyl, so 4-methyl, bute. So remember, that's 4 carbons is bute, butane, -1, 2, diol. So 4-methyl butane 1,2-diol. I have to say di here because there are 2 OH groups. If there were 3 OH groups, I would say tri. But when you have more than one, you have to indicate a Greek prefix here as well. Okay, so that's how we tackle alcohol nomenclature. So another functional group is ketones. Ketones are represented by a C double bond O. Okay, so we're looking for this C double bond O somewhere in that organic structure. And for ketone nomenclature, we're going to change the ending from -ane to -one. So alcohols end with -al, ketones end with -one. So let's take a look at the first one. It's a 2-carbon parent chain, so that's eth. And instead of calling this ethane, remember these dashes are H's, we're going to change it from ethane to ethanone. Okay, and then the next one, it's a 3-carbon prop, so propane changes to propanone. Now again, because of the 3 carbons, I am going to number off my carbon atoms, and we're going to actually specify on what carbon number is my ketone on. So as we can see, that double bond O, it's on carbon 2. So we're going to call this propan 2-one. Okay, again, that is the new nomenclature. It takes a little getting used to putting these numbers in between, but that is how we do the new nomenclature for that compound. So you go ahead and try that next ketone, and I'll obviously talk you through the answer as well, but you can pause the video. We have to number our carbon atoms. Remember what I said before, we have to give priority to the functional group, because in this structure, I see a substituent group here, that's methyl, and then I see my ketone over here. So when I number this, I want the ketone to have the smaller carbon number, so I'm going to, again, number it this way. So what I can see here is that I've got a 3-methyl, so 3-methyl, 4 carbons is bute, so butane 2-one to indicate that my ketone is on carbon 2. All right, so that's how we cover ketone nomenclature. Let's do a couple more in this video lesson, and then we can there's quite a few functional groups, so maybe we can do the next set in another video. So let's look at aldehydes. Aldehydes are represented by the C double bond O and then a single bond H, and then it's connected to a carbon chain. So we're looking for this like COH kind of component. Okay, that's your aldehyde. And in our nomenclature, what we're going to do is we're going to change the ending from -ane to -al. So aldehydes end with -al, alcohols end with -al, ketones end with -one. So try to use some of these, phrases to help you remember, but a lot of the endings are within the name. So aldehydes, this first one, it's a 2-carbon compound. So remember, let's go back to our prefixes chart. 2 carbons is eth. So eth, not ethane, but ethanal. Okay, and the next one is a 3-carbon parent chain. So it's a prop. So not propane, but propanal, and so on and so forth, right? Now, notice I don't actually have to indicate the carbon number for this one because it's always going to be carbon 1. So no matter what the aldehyde structure is, because of this like C double bond O, single bond H, that automatically has to be carbon 1 in its position. So for example, even this third structure, even if it's on this side, that's okay. This is automatically carbon 1, and then we'll just number it this way. So you don't have to put the 1 for these because it's always going to be carbon 1. Okay, that will kind of be implied. So I've got a 5-carbon parent chain. Remember, this is a substituent group. That's called methyl. So methyl is on carbon 3. This is a 3-methyl pentanal. So not pentane, but pentanal because of this aldehyde. All right, let's do a couple more. Carboxylic acids. Pretty similar, actually, looking to aldehydes. So we're looking for this C double bond O OH, or COOH. That's a carboxyl functional group. And for our nomenclature, we're going to change the ending from -ane to oic acid. So for example, this first structure that I circled, it's a 1-carbon parent chain. So it's not just going to be methane, but it's going to be methanoic acid. The one beside it is going to be, so this 2-carbon parent chain, not ethane, but ethanoic acid, right? The next one, I forgot to put these dashes here, so let's put those in. Remember, those are hydrogens. This is propanoic acid. Now, why am I not putting carbon numbers in here? Because just like aldehydes, the carboxylic acid will always occur at carbon 1. So putting 1 becomes redundant. Carbon 1, this is automatically where the carboxyl will be. And even, again, it can be on the left or right. So for example, this one, this will automatically be carbon 1, and we just number our carbons across like this. Okay, so you don't put the 1 for aldehydes or carboxylic acids because that functional group always takes the same position. Okay, in this structure, it's a 6-carbon, so it's a hex. But remember this, when you see that, that's a substituent group. That substituent group is on carbon 2, so 2-methyl hexanoic acid. Okay, let's do one more for today, which is haloalkanes. Haloalkanes are halogens. So alkanes that have halogens in them, halogens are main group 7 on your periodic table. So elements like chlorine and iodine and fluorine and bromine, those are halogens. So if you've noticed, all the examples we've covered so far, we have changed the endings. So we've changed the suffixes to -al or -al or oic acid. For halogens, we keep the endings the same. So the ending will be -ane, so ends with -ane. The prefix will be different. So the prefix will be whatever this halogen is. So the prefixes are, we call it like this. So if it's chlorine, we say chloro. If it's fluorine, we say fluoro. If it's bromine, we say bromo, and so on and so forth. So for example, structure 1, 2-carbon parent chain. So it's an ethane. So that's the ending of this compound is ethane. And then what you have to put as the prefix is, I see a chlorine there. So this is called chloroethane, all one word. Okay. And I don't have to number the carbon. There's only 2 carbons here. So the chlorine is automatically on carbon 1. The next structure is a 3-carbon parent chain. I am going to number these. And my nomenclature for this will be 1, 2 dichloro, because there's 2 of them. So 1, 2 dichloro, what's 3? So 3 is propane. Okay. And then the last 2, let's finish off the video lesson here. This cyclical structure, remember, is called cyclohexane. And then in terms of your nomenclature, I do have 2 halogens. We're going to put them in alphabetical order. So I'm going to call this carbon 1, and I'm going to call that carbon 2. So we're going to call this 1-bromo, 2-chloro, cyclohexane. Sorry, hopefully you can read that. So 1-bromo, 2-chloro, cyclohexane. And then finally, remember also what I said before, the functional groups take priority. So do I call this one carbon 1, or do I call this one carbon 1? So I'm going to have to go from right to left, because I want the functional group to have the smaller carbon number. So we're going to go across like this, 1, 2, 3, 4, 5. And I do have another substituent here besides fluorine. So there's 3 groups that we have to add to our nomenclature. So we're going to put these in alphabetical order, and the naming of this will be 1, 3 difluoro, 2-methyl, and then it's a 5-carbon parent chain, so pentane. Okay, that's how we tackle some organic functional group nomenclature. So if you have any questions, please let me know in the comments. If you have any follow-up questions, or if there's other lessons you would like to see, please let me know. And it would be so great if you could like and subscribe. And thank you very much for tuning in.